Well, hello everyone. As you've heard, my name is Giacomo. I'm an Italian developer and I'm one of the people who's helping build the Gleam programming language. I'm helping with the compiler, tooling, and, well, bug fixing. There's always plenty of that, no matter the project. And if you've never heard of Gleam, well, this is your lucky day, because you might have guessed it. I will be talking about Gleam, a friendly, functional programming language for building type-safe systems that scale. There's quite a few things to unpack in here, and we're going to touch upon those ideas. But, well, rather than teaching you all there is about the language or giving you a course on Gleam, I would like to talk about something a bit more specific, something that I think Gleam does particularly well, and that is being small, and how being small can actually be quite the feature in itself for Gleam, because it does not just shape the language itself, but also the ecosystem, the libraries and frameworks that are written in Gleam, the developer experience, the tooling around the language, but also, well, the development of the language itself, how people like me or Louis, the creator of the language who's sitting around here, go about our day making Gleam. What we have to take into account, what we have to think about whenever someone comes up to us and they have some new exciting feature they might want to get into Gleam. Because nowadays, well, we're kind of used to programming languages being this sort of ever-growing thing, where new features are constantly added. There's new, better, hopefully better, exciting ways of doing stuff. And then naturally it makes its way into our programming languages. And well, on the one hand, that can feel quite empowering and it is exciting. But on the other one, it is a bit of a double-edged sword, because as the language grows and the surface of the language grows, well, we're getting more features, more ways of doing things, but it's also harder and harder to wrap our head around the language, to get a good grasp of all that is going on with the language, to even know all the different levers that we can pull to get from point A to point B where we want to go. And so Gleam tries to do something different. It wants to stay focused, practical, and really small. So much so that the entirety of the language can actually neatly fit on a little postcard. And these are all the keywords in Gleam. And by the way, I've actually printed plenty of those postcards, totally underestimating how many 500 of them are. It's a stash this big. I will be handing them out later at the unconference if you want one. And you can really send them in the mail. But actually, I'm also kind of lying here. Because out of all those keywords, only 2/3 of them are actually in use today. All the other ones do absolutely nothing except produce an error message. So, why might that be? Well, when Gleam went V1 and we deemed it production ready 2 years ago now, we decided we would reserve some additional keywords, just in case. Maybe 10 years from now, I don't know, we do realize we actually wanted that feature, macros in the language or something. Well, this gives us the wiggle room to actually add it without introducing a huge breaking change to the whole ecosystem. And that's because we want people to be relying on Gleam. We don't want to introduce a new breaking change every time something new comes up. But, well, looking at languages keywords is fun and all, and I would say it makes for a pretty good looking postcard, but it's not the same as reading something written in Gleam. So let's have a look at some Gleam, shall we? And this might be the very first few lines of Gleam code you see, and hopefully it might have a sort of familiar look to it. Heck, you might even have an idea of what is going on here. We are defining a greet function that takes in a name, an argument, that's a string, and prints a message to standard output. And then we are reusing this greet function to print a greeting for each item in a list. Hello, Lucy, and hello, London. And well, if Gleam looks familiar, that's actually by design. That's an intentional design decision. Gleam used to have a different syntax, actually, back in the days. And then we realized people had a much better time learning it when it looked more like other, more mainstream programming languages. That's because, well, Gleam is a functional programming language. And if you come from a different background, maybe doing object-oriented or anything else, it might take a bit of getting used to. There's no way around it. You get to learn new ways of doing things. And, well, if the language looks really unfamiliar and alien, now you have to juggle a lot of things in your head and learning becomes twice as hard. And this actually brings us to our first point. Gleam is a small language. But it is not small just for the sake of it, just because one day we woke up and thought, well, let's try and make a language that is as small as possible. No. Well, being small can actually be quite the feature in itself. And I think we rarely value it highly enough. Because being small can make, for example, for a language that is fun to learn. A language that has a great focus on having a small, well-defined core with a basic set of features that can feel quite powerful, but at the same time, it does not grow over time into a huge mess. And well, this might remind you of other way more popular languages. Like Go, for example, which is known and loved for being a language that is easy. It does not have heaps of features, but at the same time, people have been writing amazing pieces of software with it and can feel quite productive using it. Or even this idea, I think I first read it in the Zen of Python, of not having two ways of doing things. I have no idea if it applies anymore. I haven't written any Python in a short while. But I think this applies just as nicely to Gleam. For example, Gleam does not have if statements. Yet Gleam is a Turing-complete language. It wouldn't be all that useful otherwise. And that's because we can do control flow using a different feature. That is with case expressions and pattern matching. So here we're saying in case user is admin is true, well, we do something. In case it is false, we serve a not found page or whatever our application might need to be doing. And well, if you've never heard of case before or pattern matching, you can think of it as a sort of switch statement, a bit more powerful. We're not going to dive into the weeds of how all this works. But, well, coming from languages like JavaScript, Java, or C, it might feel right at home thinking of it as a switch statement. And if you look at it, well, if expressions are not needed at all, this is already plenty enough to deal with booleans, so we just got rid of another different way of doing the same thing. And while that might feel silly or limiting at first, I think it can be quite nice. Because then you don't have to think, well, should I use an if statement here? Or a case expression? Which one would look better? Maybe we should decide with our team on some practices, on some guidelines to follow so that we know that here we should use if statements and here we use switch statements and whatnot. But, well, sometimes having too many choices is even worse than having no choice at all. And we just got rid of this different way of doing the same thing. I think this also has the nice side benefit of not making booleans all that special in your language, since now they no longer have this special construct just for them. And we did realize, well, boolean blindness is actually a problem because reasoning about those pesky booleans, as soon as there's more than a couple of them, well, it becomes really hard with this explosion of possibilities. And so here maybe we do realize, well, the world is a bit more complex than just having admins and not. Our users maybe are better described using roles. A user could be an admin, a moderator, or a regular user. And then refactoring is also a bit nicer since we don't have to switch between the different ways of working with booleans as opposed to working with other custom types, like here. Now, I'm talking about a functional programming language, and Gleam is functional, allows us to define custom types, for example, and make sure that we don't mix things up. That, for example, we're not passing a boolean where a custom type is expected, or an integer where a string is expected, and so on and so forth. And talking about a functional programming language with static types, strong compile time guarantees, well, that might conjure up ideas of a language that is really hard to understand. A language that is really hard to master and to grok and to get a good grasp of what is going on with it. Maybe some kind of ivory tower thing born from academia to explore programming concepts, but not really meant for the layman to write the code in anger. Well, Gleam couldn't be any further from that, because this idea of simplicity doesn't just apply to some parts of the language, having a few set of keywords and features, for example, but to the entirety of it, to its type system as well. And so we like to say that Gleam is a state-of-the-art type system, but from the 70s. So, so it relies on some very well battle-tested ideas that have proved to work over time, to make our code easier to reason about, to write, to refactor especially. So in Gleam, we can define custom types. A user here could be either logged in or anonymous. And well, if you squint hard enough, that is basically an enum. And you would be right, it's basically the same thing coming from C or JavaScript or Java. But we can also go a step further and say, well, a logged in user also has some additional pieces of information, like a name, that's a string, or an email, another string. Or maybe we could say, well, the email is actually an email type to represent a validated email, not just any possibly random sequence of characters. And really, if you look at this slide, there's basically, I would say, 80% of the entirety of Gleam's type system here. It doesn't get much more complex than this. There's generics, and that's it. That's the whole story. So it is really a simple language, a tiny language, even when it comes to the type system. You won't be able to run dooms with your types, like with TypeScript, for example. I think that's actually a good thing sometimes, being limited and small. But again, being small, while it can make for a language that is really fun to learn, can also have some other really nice properties. Because being small also means that a language can be delightful to use. Now, when the language actually gets out of the way, we can focus on the problem at hand rather than all the machinery involved in the language, all of the different features, how they interact with each other, how we should use one or the other, and when we should do it and when it looks better, maybe coming up with practices and so on. And then we don't have to think of all those levers we need to be pulling, even left wondering, why do we even have that lever? Gleam really does optimize for readability here, not terseness. And that is a trade-off. Well, of course it is. We're developers. We know that everything is a trade-off, sadly. But what you get is, well, Gleam takes a bit more typing. It is not a super concise language. You will not be able to squeeze as much as possible out of a single incredibly terse line of code, but in return, you get code that is easier to follow. There's no implicit control flow. There's no implicit conversions. You have to be explicit about what you're dealing with. And you get errors if you're not. The compiler is not trying to be helpful and actually backfiring, trying to do the implicit conversion for you. There's no exceptions and no nulls as well. And so you have to be really explicit. Again, you will be typing a bit more. But if you think about the fact that, well, we developers, we actually do tend to read code way more than we are actually writing it. We have to maintain code written by others. We have to fix bugs written in code written by others or by ourselves from the past, our worst enemy. And well, if I'm thinking about myself a week from now, maybe a month from now, or a year from now, God forbid, well, I wish for them to have a good time reading the code that I wrote. And so I think it is a nice trade-off to try here, to try and optimize actually for readability rather than terseness. And being small is what enables us, developers writing the Gleam language, to actually focus on other things that we think are quite important. Because a language that is easy for humans to understand is also a language that is easy for tools to analyze. And so that allows us to focus on experience and tooling. For example, well, thanks to Gleam's pretty straightforward type system, the compiler can give us really nice error messages here. Here we're trying to access a .alias field from a user, and well, it's telling us we are trying to access something that is a user, but it only has these fields, .name. Maybe we meant to do that. And I think it is really nice that the compiler can actually go the extra mile here and try and be helpful and suggest what we might have wanted to do. And that's because the code being this simple and straightforward and easy to analyze, well, we can actually do quite a fair amount of static analysis and understand what is going on with the code and, well, what the context is and what you might have wanted to do. Maybe here I was through a big renaming or a big refactor and I forgot to update one of the fields and it was stuck in an old name. And, well, that allows me to just go back to all these little hints, fix them and go on with my day. But also, well, here we are really resting on the shoulders of giants like Rust and Elm, which are really two amazing languages at showing us what great error messages should look like. Rust might be a language with a steep learning curve, but I think everyone can agree who has tried Rust that the error messages that it produces are actually quite nice. And they actually can make the developer have a much better time at learning the language, at grokking what is going on. And well, the same goes for Gleam. And yet this is not enough. A language might be small and easy to learn, small and fun to use, easy for tools to analyze and have great error messages. But nowadays, well, we can't just give a developer a compiler and tell them, go figure it out. Go figure out package management, how you should scaffold your projects, and so on and so forth. Because we're kind of used to all those pieces of tooling, which, well, are not really part of the language. To much of my despair, because I really love writing programming languages, what actually really matters is all the things that are actually around the language. And the language itself is only a very tiny piece of the picture. Because a language is only as nice to use as all the tooling around it, and how this tooling allows us to use the language. For example, to package our code and deal with dependencies, build documentation, build our code and run it and test it, and also format our code. We don't want to be fighting with our coworkers under pull requests because a comma should go here, not on a new line, or a parenthesis should go here and not on a new line, and so on and so forth. And so Gleam learns this lesson, and Gleam being small allows us, the developer working on Gleam, to focus on all of these pieces of tooling around the language that are just as important, if not more important, than the language itself. They are usually what makes or breaks a language for developers. Because if a language is really nice, but you want to pluck your hairs out when you're trying to then deal with dependencies, then you need to figure out which dependency manager you need to use, which package manager, which configuration file you should be using. Well, that is not a pleasant developer experience at all. And so Gleam comes with those tools built into the toolchain. Once you've installed Gleam, well, you're pretty much good to go. So, for example, if we need to create a new project, well, that's Gleam new, and that's it. The build tool built into the toolchain scaffolds your project, and then, well, we can follow the hint, go to the directory and try and test our code. And that's with Gleam test, compiled, and then the tests are run. And that's it. We need to run our code. Well, you know the drill. That's Gleam run. And there's actually so much more to it that the CLI can do. It actually wouldn't fit on a single slide unless I made the font really small, so there's just a part of it, which I think is good. But, for example, it can deal with dependencies. Package management is built into the box. It can build your project, of course, but also your documentation when you need to browse it locally. It can deal with tests, with your development setup, and so on and so forth. And well, if you want to check it out, we're going to have plenty of time at the unconference later, or you can try Gleam out and see what the command line can do for you. And really, so far, we've talked about languages being small for being easy to learn, fun to use, and also easy to analyze, and to have great tooling. And well, that is important, and all of those, I would say, are pretty technical concerns. So, well, we developers love those. I do love those. Trying to fix every single bug, trying to come up with the best error messages possible, or the best developer tooling and error messages. But, well, technical concerns are not all that important. And I would say that being small is actually quite the feature for Gleam, for something that is not really all that technical. Because being small is what enables Gleam to be truly a community project, is what allows Gleam to achieve its goals without having any big corporate owner. What do I mean by that? Well, Google is not a corporate-owned language. It's not a Google or Microsoft language. It is not backed by VC capital and huge flows of money. But it truly is an open source project in the truest sense of the term. It was born from the idea of a British guy who thought, well, what if this bit I love from Rust and this bit I love from Go and this thing I love from Elixir were merged into a single language that I enjoy using in my day-to-day work. And well, it is really important for us to be able to achieve these goals while at the same time maintaining these Linux ideals of being open, built in the open, being an open source project with a community around it, building a community as well. And well, Gleam is supported by a lovely community of people. Last time I counted them, there were more than 300 people, I think, who supported Gleam with pull requests, fixing bugs, opening issues, sharing ideas as well, sharing blog posts, their experience using Gleam, their gripes with Gleam. I love those because those are so important for us to understand what we can do better. And also people are, well, donating to the project as well. That's how Gleam can go by. All the lovely people who have sponsored Gleam so far can be seen here. I think it's more than 300 of them at this point. And that is the community that we cherish and we are trying to build that is also helping the project grow. Because if you look at it, well, the team working on Gleam is actually quite small. It's 3 people. That's me, Giacomo, Louis Pilford, the creator of the language, and Surya Rose, another amazingly talented developer. And while I'm really lucky to be working with these amazing developers and engineers, but there's only so much so that 3 people can do. And whenever we think about what we need to be adding to Gleam, what we need to do for Gleam, well, that comes with a lot of questions. Well, usually the way it goes is I go to Louis and I'm like, well, we should add this to the language, or we should do this and have that, and so on and so forth. And then Louis is really good at talking me out of it, which I think is actually really, really good, because we need to think about a lot of things whenever we're working on Gleam. And being small, not just in scope, but also as far as our resources are concerned, can actually be a feature in itself quite counterintuitively. Because that brings us a sort of clarity and focus that we wouldn't have otherwise if we had heaps of money to throw at every problem we find. Like, what is the thing that is going to have the most impact for us? Or, well, what is that really matters to us? Do we really need this feature? And actually, can we afford to maintain this over the long run? Because, well, as nice as the new feature is, once you hit merge, well, that becomes yours to maintain for a long time to come. And if we want people to rely on Gleam, well, we can't just merge absolutely everything and then, well, try and remove it later and introduce breaking changes if we do realize that the feature was not actually all that good or not that needed. And all those questions, well, if you didn't listen to a word I said and you had a look at this slide, they can just very well apply to any software project, really, or any human endeavor at all. Find your battles. Find the thing that matters the most to you, and then try and do a good job at it with the resources that you have. And even being limited can be a feature in itself. For us, those battles look like a language that is fun to learn, but also delightful to use. A language that has the best developer tooling experience that it can give you. Thanks to being small, that is what we have been able to achieve, despite being a very small team, while at the same time building a community of lovely people. Well, I joined Gleam because I thought it looked cool, but really what made me stay was the people around it, and how cheerful everyone was, and how the language really has this buzz around it that is really hard to get any other way. So this is Gleam and the value of small. If you want to try Gleam out, you can do so at gleam.run. You can find me at giacomocavalieri.me, that's my website and my Blue Sky handle. And well, I thank you so much for listening to me today, and I hope you have a lovely rest of a conference.